Hello, and thank you for joining me here at PlatformCon 2025. My name is Cornelia Davis, and I've been doing this platform engineering thing for more than a decade. That's right, longer than the term has even been in vogue. That comes from my time at Pivotal working on DevOps and developer platforms, in particular with Cloud Foundry. What we're going to do today, my developer friends, is talk about building distributed systems. You are, of course, developers. The applications that you're building are for things like infrastructure provisioning, user onboarding into your IDP, software deployments, and much more. Our agenda for today is to take a look at two use cases in the platform engineering space. Then I'm going to introduce you to Temporal. And then we're going to revisit those use cases, in particular the second one, with a live demo to see how we can bring resilience to that distributed system. And then finally, I'll close out by inviting you to learn more. So, looking at that first use case, infrastructure provisioning, let's take a simple scenario. We want to create an auto scaling group. We want to create a VM. We want to add that VM to the auto scaling group. And then we also want to add certain artifacts to my monitoring system. That monitoring system might be external. So, the first three things might be all involved in something like GCP or AWS, but I might have an external monitoring system. So, I've got a very heterogeneous environment there. Now, what are some of the challenges that you're going to face in programming this distributed system? Well, resilience of your automation. If you've got this in scripts, what's going to happen? How do you make sure that script is going to keep running? So, resilience of your automation is key. And then, if it doesn't run all the way, do you have to start dealing with orphan resources? So, if I create the auto scaling group successfully, but then something goes haywire, how do I recover from that? And it might be relatively easy for you to create these things using some declarative configuration. But as soon as I do this, not only for one infrastructure, but I'm doing it for dozens or hundreds of infrastructures because each one of my users in the IDP gets their own environment, then it becomes untractable. And finally, observability. I'm not talking about the observability of the infrastructure itself, but the observability of your distributed application, the observability of your automation here. Now, in order to meet some of these distributed systems challenges, we might set up an architecture that looks like this. You've got some automation that's running in the middle, and in order to communicate with these downstream services like an autoscaler or compute service or monitoring service, we're going to employ queues, for example. Or if I'm making direct calls, I'm going to implement some retries to handle things like network outages. I'm going to create a cron job, which is going to occasionally look for orphans and clean those things up. And I already mentioned that declarative configuration can help in some cases. I, of course, am also going to introduce things like maybe rollbacks. So if something goes wrong, I can roll back and undo what I did beforehand. And all of those things are things that you need to deal with. You can't just build that automation. If we look at a second use case, let's say user onboarding, we are bookended by the same two concerns, resilience and observability. But we might have some additional challenges in the middle, things like human in the loop processes. So the user has to provide information, or maybe somebody has to uh, deliver some approvals along the way. And we might also have long running processes. And now I'm not only talking about things that run for minutes or hours, like some of your infrastructure provisioning might, but because we have these human in the loop processes and they might take a very long time, I'm talking about processes that might run for a day, 2 days, 7 days, even months or longer. How will we deal with that? Well, the picture looks very similar. Again, I've got these downstream services and I'm creating queues and retries all over the place. Now, I didn't mention it in the previous example, but when we start having these distributed event driven systems like this, we start to use things like state machines to manage the state across this distribution. Anybody who's done that knows that these things get very complex very quickly. And when we start doing things like rollbacks in that scenario, it gets even more complicated because we have to decide what messages we're dropping in which queues to undo things. Now, adding to that complexity is the realization that any one of these components that are a part of your architecture, your distributed systems architecture, can go down. So we can have queues going down, we can have downstream services going down, we can have network availability blips, and this makes things even more challenging. So let me now introduce you to Temporal. Temporal is a technology that is entirely open source. Most of it is MIT license, except for just a little bit of Apache too, and I'll clear that up in just a moment. What Temporal does is it supports a programming model that allows you as the developer to code the happy path. And all of those distributed systems concerns and all of that infrastructure that you need for it, the queues, the retries, and all of those types of things are handled for you behind the scenes. This platform comes in the form of a service and some SDKs. The SDKs are available in Go, Java, Python, PHP, TypeScript, .NET, and Ruby, allowing you as the platform engineering developer to code in whatever you want. No DSL necessary. Now, here's a picture of what this looks like. You're going to code your automation the way you normally would, but now you're coding just the happy path of the onboarding user. You've connected that to a Temporal SDK, so your application has the Temporal SDK built in. And this is a great point for me to talk about the fact that the part of our platform here that is Apache 2 licensed is the Java SDK. So all of the other SDKs are MIT licensed. So your application runs with the SDK and that connects to this temporal service. As you can see, the temporal service has embedded within it things like queues, timers, retries, managing state machines. All of that is built into the temporal service. So you can think of this as resilience as a service tied to your application. And this allows us to now create workflows, and I'll define that more in just a moment. It allows us to define workflows for all of these different applications that you're building, all of the different automations you're building, whether it's provisioning infrastructure, user onboarding, rolling your infrastructure, all of those types of things can be programmed as temporal workflows. So let me talk about the programming primitives with Temporal. There's really four fundamental ones. There's the workflow. You can think of this as the application main. So it is the thing that's going to orchestrate all of the different steps that you want to do as a part of your application. Oftentimes, those steps are going to be a little bit less predictable and making calls out to third parties. And what you're going to do there is wrap those calls in what we call an activity. This is what leverages the SDK. Then I mentioned earlier that we have long running workflows. And we have human in the loop. So when a human wants to provide some content that is going to drive the workflow forward, that is done through something called signals or updates. It's a way to inject into a running workflow. And then, of course, you want the ability to look at how things are progressing in your workflow to see whether anything is stuck, needs additional attention from, let's say, one of those humans in the loop. So those are the four fundamental programming abstractions. Now, I didn't call your attention to it on the previous slide, but I want to now. And the point here is that once a workflow starts, it will run to completion, regardless of any type of challenges that we see in the distributed system. Downstream services going down, it'll keep running. Brief network availability blips, it'll keep running. Even the workflow itself crashing, it Temporal will reconstitute that workflow when the application is restarted, and it'll pick up where it left off. That is really key. And we call this durable execution. What it means is that once you start running something, again, it's going to be crash proof. That doesn't mean it won't crash. It means that it's resilient to those crashes. Think about it like your waterproof watch. A waterproof watch doesn't mean that you're not going to get it wet. It means that when it does get wet, it still survives. So instead of being responsible for something that looks like this, you can build your workflow that looks like this. The user onboarding flow has a happy path, and that's what you see on the right-hand side. It uses activities to make calls out to things like the payment service and the user creation service or the user management service. But then in this particular case, the business has decided that what we want to do is allow people 7 days, 1 week to do an onboarding. And if they don't complete it within the week, we're going to go ahead and clean up after them. And it's going to be as if they never signed up. So we have timers. And then when that timer fires and we need to cancel the happy path, we'll clear out the rest of the remaining things in the happy path. And then we will compensate for that by, for example, in this case, refunding a payment. And I'm going to show you this in demo form. And in fact, we're right at that point. The first scenario I'm going to show you is the happy path. Everything is functioning great. So let me orient you to what we have here. On the top left, we have the form that the user is filling out because they want to get onboarded into this platform. What we have in the lower left-hand corner is I have a little bit of visibility into the two backing services that are involved in this workflow. So the user management service, and that's what you see with the user list, as well as the payment service. I've got some buttons in there that are going to allow me to pause those backend services, in essence, simulating an outage of some type. And that's going to allow us to run through these scenarios. So again, the first scenario is the happy path. So I'm going to come here and I'm going to onboard myself. I'm going to click the submit order button and come over here. And what we can do is see the workflow running. And in fact, it's already completed. Let's click in and have a look. So what you can see here is that I started a workflow. It processed the payment. it recorded the user, and then it made a downstream call to another workflow to provision the resources. The thing that you see here in the little yellow button or the little yellow bar was the timer. Now, in this case, it all happened well before the 30 seconds. You can see here that it happened actually in roughly less than 30 milliseconds. And you can see all the steps that it went through to succeed in this onboarding process. In the second scenario, we're also going to be going through the happy path, but this time when we try to process the payment, we have trouble accessing the service. Before I try to onboard Angie, I'm going to simulate an error in that payment processor service by clicking this button. We now submit the order, and coming over to the workflow, we can see that it's running, and we can see that we're having trouble processing the payment. I'm going to clear the error from the payment processor, and in just a moment, we should see that recover. And indeed, it does. The process payment completes, I record the user, and then I provision the resources downstream. So what we've done there is implemented some retries at the back end on your behalf. In the third scenario, we're going to simulate there being some type of a delay in the record user process. Perhaps it's that we've sent them an email and asked them to verify their email and they haven't done so, or maybe we're waiting on approval from somewhere else. The timer is going to fire. Of course, we're not going to wait 7 days. We're going to wait a few seconds, and then we'll see how the compensation happens as a part of the flow. To simulate this scenario, I am going to cause a problem with the user service. So that's going to pause. We're going to allow the payment, however, to go through. So now, trying to onboard my colleague Mason, we take a look at the workflows and we come in here. Again, you can see that we've processed the payment and now we're trying to record the user. I'm going to pause the video here and we'll wait for the timer to fire. Okay, now we see that the timer has fired and we've canceled the remainder of the happy path. So you can see here that we were trying to record the user, but we've stopped doing that. And instead, we've gone to the compensating steps. So you can see here that the refund payment went through. You'll also notice, of course, that Mason wasn't added to my user list. And now in this final scenario, we're going to do something very similar to the previous one, except that when it's time to refund the payment processor is going to be down. In order to simulate this scenario, we have the user service status is that it's currently down. The payment processor is up. So we're going to take the payment. I'm going to try to onboard Mason again. I'm going to click submit order and come over here and take a look at the workflow. The workflow is running, so we're familiar with this already. But before that timer fires, I'm going to set an error in the payment processor. So now the payment processor is down as well. So let's see what happens when the timer expires. And there you have it. The timer has expired, and we can see that the recording of the user has been canceled. But now we're still trying to refund the payment. The payment isn't able to be refunded because the payment processor is down. Let me clear the error out of that. And in just a moment, we should see the refunding of the payment should be successful. And there we go. So, in spite of the fact that the payment processor was down when we were trying to compensate for the failures or compensate for the timeout, again, as I said earlier, once the workflow starts, it is guaranteed to complete, even in the light of all of these different challenges. So, wrapping things up, here's a review of the different scenarios we looked at. Everything went fine. In the second scenario, we had a sporadic failure of the downstream service, but it got through the happy path. In scenarios 3 and 4, we had some timeouts and we had to compensate, both when the compensations happened, no problem, and when we had to do some retries to get the compensations to fire. I could stand here and go through another half a dozen or dozen different scenarios of failures and show you how temporal compensates for all of those. So I thank you for your attention. I want to leave you with this invitation. The demo that I showed you here is in a GitHub repository, and you can get there through this QR code and this bit.ly link. We also have a set of resources that are available to you that show you how you can get started with Temporal and how you can get the most out of Temporal for your platform engineering use cases. You're also, of course, more than welcome to reach out to me. Here are my contact details, and I look forward to hearing from you. Thank you so much for your attention, and we'll see you soon.